All right, good afternoon, guys. So we are going to be continuing our discussion of logarithms today. And I want to go ahead and point your attention to example 1 here. This logarithm should look almost exactly like what you saw yesterday, except for one thing. There's only 2 numbers in this equation, so let's talk about why this is. So this is still a logarithmic equation, but normally there's a little number called your base that sits right here between the word log and that number 100. The reason that there is no number there is because it's understood to be 10. And if the base is ever 10, there's a shortcut that says you don't have to write it. So if they ask me to rewrite a logarithmic equation and there's no little base here, I just assume that it's a 10. So if I want to rewrite this in exponential form, watch what I do. Okay, so I assume there's a 10 here. So I'm going to write the 2 numbers that are on the left side down. So 10 equals 100. And then the number that's by itself, remember, is always my exponent. So this is going to be a 10 squared. And again, I've made a true statement. Okay, 10 squared equals 100. If you look at number 2, I've got sort of a similar situation here, except for I have the letters LN written right here. That stands for natural log. And don't ask me why the N does not come in front of the L. They did not ask me my preferences, so that's the way it came out as LN. But LN, again, stands for natural log. And here's what it means. If you see LN, it means that the little base here that's missing is understood to be the letter E, okay? And to explain what E is, remember back when you learned that pi stood for the number 3.14. Well, E is just like that. E stands for the number, it's approximately 2.7, but that number goes on forever and ever. So if I want to rewrite this logarithm in exponential form, I'm going to use this time the letter E instead of 10. So I'll have E equals 20.086, and again, the number by itself, that 3, is my exponent. So I have e to the third, or about 2.7 to the third, equals 20.086. Okay? Now I can also go backwards. Let's say I see something like number 7, and it says, here's an exponential equation. I want you to write it in logarithmic form. Well, the first thing that I notice here is that there's an e. That means that I'm dealing with a natural log here. Okay? So if I want to change this to logarithmic form, I'm going to go ahead and the first thing I'm going to type is LN, and again, that's because of the letter E. Here's what I do next. The E and the 20.086 are the ones that would go together here. So E and 20.086. The exponent always goes by itself. But here's the thing. Because with a natural log the base is understood to be E, I don't have to type the E if I don't want to. Now, if you do, it's not wrong, but normally just as a shortcut, people don't type the E there. But I will not count that wrong if you do. Let's say I go to number 8 now. Well, number 8, I notice that my number right here is 10. Well, if I'm dealing with the number 10, that's not a natural log, that's just a regular log. So if I want to write this in logarithmic form, the first thing I do is I write log, okay? My big numbers, the one on opposite sides of the equal sign, are going to go together with the log. So log base 10 of 1/10 equals, and the exponent will go by itself. So -1 goes over here by itself. But again, because the base of log is understood to be 10, I don't actually have to write it if I don't want to. If I do, it's not wrong, but I don't have to. Okay? So there's how you go back and forth between logarithmic and exponential form if you're missing that little base. The other thing I wanted to talk about is how you evaluate logarithms. So if you notice number 1 says evaluate, and all it says is log base 5 of 125. What it's wanting to know if it says evaluate is what does that equal? Well, we don't really know off the top of our heads, so what do we do when we don't know something? Well, we call it x. So I'm going to type equals x right there. And my next step, if I want to evaluate this, is I'm going to go ahead and change that now to exponential form. Well, how do I do that? Well, the number, or in this case, the letter that's by itself will be my exponent. So this is now going to say 5 to the x equals 125. Okay? Well, what is x? 5 to the what power gives me 125? Well, that's 3. So in this case, my final answer is just 3. So what is log base 5 of 125? It's 3. Another way to think of that is it's saying 5 to the what power is 125, if you don't want to write all that out. Okay? Number 2, same thing. It says the natural log of 148.413 equals what? I'm going to change that little question mark there to an x because that's what I don't know. And then I'm going to rewrite this in exponential form. Well, because I see that that's a natural log there, that means I'm using the letter e. So this one's going to say e to the x equals 148.413. And here's the thing, nobody has their e to the what power, they don't have that memorized, okay? Off the top of your head, you're not going to know what x is. So just test a few numbers and see which one is correct. In this case, it ends up being that e to the 5th is 148.413. So your final answer here would be just 5. Okay? Very last example, they want me to evaluate the log of 1,000. Well, since I don't know what that question mark is, I'm going to change that to an x and rewrite it in exponential form. Since this is a regular log, I know that little number that's missing there is a 10. So when I rewrite this in exponential form, it's going to say 10 to the x equals 1,000. So 10 to the what power is 1,000? Well, again, that happens to be 3. So my final answer there is just 3. So again, evaluating is just saying, what does this thing equal? You are welcome to type that in Desmos. If you have questions about that, I'm happy to help you. But these little examples just show you how to do that by hand. So go ahead and get started on today's quizzes. Feel free to let me know if you have questions.